Hi everybody, in this lesson we're going to be looking at how to deal with categorical variables in a regression analysis. That is to say, variables that are measured at the nominal level of measurement. As you start working on the data analysis for your own research papers, it'll be really important that you pay close attention to this lesson and that you fully understand the intuition behind everything that I'm saying. Undoubtedly, some of you will want to or need to include categorical variables in your regression analysis. And if you're not extremely careful with these types of variables, you're going to get a regression output, but it's going to be meaningless. So that's the plan for this lesson. We'll look at how to deal with categorical variables in a regression analysis. And just like a few weeks ago, we said that it doesn't make any sense to calculate an average of a categorical variable. It likewise doesn't make any sense just to plug a categorical variable into a regression equation. As you'll see in this lesson, you can only include dichotomous variables in a regression analysis. If you have more than two categories on your nominal variable, though, you can still include it. You just need to do some extra data manipulation before you start running your regression. So let's look at both of these points. Before we do that, though, let's just recap our interpretation of basic regression coefficients. By now, you should be able to do this pretty easily. So what I'd like you to do is take a minute and make sure you can interpret the regression coefficient that I have highlighted on the screen in yellow next to ideology, this coefficient of negative 11.743. We've been looking at similar examples in the previous lessons, but just remember that the dependent variable in this analysis is the feelings thermometer about Obama, and that ranges from 0 being cold to 100 being warm. Similarly, ideology is measured on a 1 to 7 scale, with 1 being very liberal and 7 being very conservative. So given that information, how would you interpret the coefficient on ideology? Well, as you should have remembered, the intuition, because this is an OLS regression, is fairly straightforward. We can say that a 1 unit increase in ideology is associated holding all other variables constant, because this is a multivariate model, is associated with an 11.743 decrease in our feelings thermometer dependent variable. The next thing I would ask, though, is how would you interpret the coefficient on the variable labeled female, this coefficient of 3.625? Again, this is a binary measure of the respondent sex taken from the American National Election Study, and it's coded in this analysis such that 0 equals male and 1 equals female. What do you think? Well, as you're thinking about that, remember we said earlier that we can think of regression coefficients, generally, as the slope of a line. In a bivariate regression, this intuition is fairly straightforward. The equation that we get for a regression line is y equals a plus bx plus error. In other words, the predicted value of our dependent variable equals the y-intercept, or constant, plus the coefficient on the regression equation times the independent variable's value plus some unexplained error. And we said that in multivariate regression, this intuition gets a little more abstract. In this case, we can think of each coefficient as a partial slope. This is why, in our interpretation, we have to say we're holding all other variables constant when we're interpreting one of those regression coefficients. But interpreting coefficients as slopes, as we've been doing in the previous lessons, that is to say, interpreting them in terms of rise over run, to use language from algebra, this only makes sense if the values that we have take on numerical properties of real numbers. That is to say, increasing values of our variable make some sort of intuitive sense. To do this, we have to be working with interval, ordinal, or ratio level measures. With categorical variables, though, the interpretation is a little different. And it's different because it doesn't make any sense to say a 1 unit increase in sex or a 1 unit increase in race. We have to interpret them differently. So, with categorical variables, rather than thinking of the coefficient as a slope, we can think of the coefficient as shifting the regression line up or down the y-intercept, depending on whether it has a negative or a positive value. In other words, these coefficients, for instance, like the one highlighted here on the variable called female, these coefficients on categorical variables are not partial slopes. They're something different. So let's look again at our previous example. And we would say that on average, again, assuming that the model is fully specified, that we're holding all other variables constant, the relationship between ideology and the feelings thermometer measure for male respondents is the same one that we looked at on the previous screen. 68.54, which is our intercept, minus 11.74 times the ideology measure, plus that unexplained error. For women, though, we can think of the slope of this line, that is to say the magnitude of the relationship, as being exactly the same for men and women. That is to say, for women, a 1-unit increase in ideology also causes an 11.74 drop in feelings about Obama. But in this instance, we have to take that coefficient on female into account because female is the variable that's coded 1. It has the higher value. So we would say that this parallel line for women is 3.62 feeling thermometer units above the line for men. That is to say, if we rewrote our equation for women, it would look like this one. Instead of the line starting at 68 on the y-axis, it would start at 71.54. And then the rest of the equation looks the same. Minus 11.74 times the ideology measure plus the error. So in the previous example, we were using a binary measure. That is to say, a dichotomous variable that can only take on one of two values. We coded one of those values 0 and the other one 1. And for ease of interpretation in that analysis, I recoded the 11 people in the ANES who answered the self-identified gender question as other. I recoded them as missing values. So why did I do this? Well, I did it because in regression analysis, you can only include categorical variables in your model if they're dichotomous. So to make things easier, I just arbitrarily dichotomized that variable. And to have any meaningful interpretation, not only did I have to dichotomize it, I had to recode it so that one of the values was 0 and the other value was 1. If we don't do this, then interpreting that shift in the y-intercept, again, doesn't make any intuitive sense. But what if we have a nominal level variable with more than two categories? For instance, religion, and we don't want to collapse it into a binary variable. For instance, 0 non-Christian, 1 equals Christian. If we do this, we lose a lot of important information that we want to account for in our regression model. So what do we do if we have to use dichotomous variables? Well, what we do is we have to create a set of mutually exclusive dichotomous variables and then exclude one of these that we created from our model. So what does that mean? What does that look like? Well, we can go back to political party identification. The American National Election Study, it asked a question like this, and the values that this question take on are Democrat, Republican, and independent. So 1 is Democrat, 2 is Republican, 3 is independent. And you'll recall from some earlier tutorials where we were interested in partisan differences across different questions or variables, I dropped the independents from the sample data, again, just for the sake of ease of interpretation. But what if we want to account for the independents in our model? And in reality, we should be doing this. Again, this is important information that we need to take into account. Well, if we want to do this, we can't just throw this variable that's coded 1, 2, 3 into our regression model. Excel will calculate something for us. It's just going to look at these numbers and nothing else. But if you do this, you've just misspecified your model, and the coefficient that you get on all of your variables in the equation are going to be meaningless. What we need to do instead is create 3 dichotomous variables. These are going to be mutually exclusive, and they're going to refer to each possible outcome on that question about party identification. So if you look in this sample data set under column B, where it says party, the first person here is coded as answering Republican, which would be the 2 response outcome. And if you look to the right of that, you'll see that I have created 3 variables, one called Democrat, one called Republican, one called Independent. These are 3 yes/no questions. And for Democrat, I've coded them as 0. For Republican, I've coded them as 1. And for Independent, I've coded them as 0. If we look a little further down, we might see on line 17, this person indicated 1. They're a Democrat. So in the Democrat column, they get a 1, and then they get a 0 in the Republican and the Independent columns. So why do we do this? Why do we create these mutually exclusive categories? And then, like I said earlier, why do we exclude one of them from our model? Well, you'll remember from earlier in this module, one of our assumptions about linear regression is that there can be no perfectly linear relationships among our independent variables. And what you just did was you created 3 mutually exclusive categories. So by definition, your inclusion in one of the categories perfectly predicts your exclusion from the other 2. And you'll also want to remember how we interpret the regression coefficients on categorical variables. Remember, these are not partial slopes. Instead, they're moving up or down the y-intercept in relation to some baseline category. In the first example we looked at, we were examining how women moved up and down the y-axis, and implied in that is relative to men. So whichever one of these categories that we exclude from the regression, that's going to be our baseline or our reference category that we're going to interpret the coefficients for the other categories in relation to. So like I said, we technically did this in the respondent's gender example. And we included the female category, and by virtue of doing that, we excluded the male category. I could have done this, right? If the question about respondent's gender had been coded 1, 2, I could have created a variable called male, a variable called female, and filled in with 1s and 0s to make these mutually exclusive 2 categories. But I didn't need to do that because it was already coded 0, 1. It was already dichotomized for me. But as you saw here, if we have more than 2 categories, then we need to do this special extra step. So let's look at one more example, and what we'll do here is we'll go back to the feelings thermometer example we've been looking at all throughout this module. And what I'm going to do is I'm going to swap party identification, which is this 3 response option categorical variable. I'm going to swap that for the ideology variable that we've been looking at so far. All right, so you've already seen this output on the left side of the screen. This is where I did my data management, and I went through, and after sorting on the party variable, went through and filled in with my series of 0s and 1s, depending on how they answered party. So when we go to run the regression, whatever's here in column A, this is going to be our dependent variable. We're going to ignore the column that we recoded, and our independent variables are going to be everything to the right of that. So what you see here is the regression output you would get if you made a little mistake and you didn't exclude one of these categories. I say here at the top of the screen that we want to exclude Republicans as the baseline category so that we can interpret Democrats and Independents in relation to them. In this first example, I didn't do that. I accidentally included Democrats, Republicans, and Independents. In terms of estimation, this isn't hugely problematic. You're going to get the same model, but what you see is that Excel recognized that perfect multicollinearity on this set of 3 dichotomous variables, and it automatically dropped the first one from the analysis. So it took the decision away from us to exclude Republicans as the baseline category, and here Democrats are the baseline category. But to fix that, it's easy enough. We just rerun the regression, exclude Republicans, include Democrats and Independents in our model, and then what we get is something that looks like this. And we can say that if we want to know how partisan affiliation affects feelings about Obama, we would say holding everything else constant, both Independents and Democrats, because these are positive numbers, they're significant, they have warmer feelings about Obama. And if we wanted to know more than that, we could use our regression equation to calculate a series of expected values. So to recap the main points from this lesson, we've said you can include categorical variables in a regression analysis, but you need to be very careful about what you're doing. Just like you can't average a categorical variable because the resulting statistic is meaningless, you can't simply plug a nominal level variable into a regression model. You have to do some extra data manipulation. First, you need to create a series of mutually exclusive dichotomous variables, and then you need to pick one of these dichotomous variables to exclude from the regression analysis. The excluded value will be the baseline category that you compare all of the other categories to.